Okay, here we go on problem number 14b. 14 is a two-step problem, and because we're doing B, I'm going to show you both steps. So the first part of the problem asks for a jet plane traveling at 88 meters per second north lands in a runway and is decelerated uniformly to rest in 11 seconds. So we have givens that say that initial velocity equals 88 meters per second. It does say that it decelerates to rest, which means that it comes to a stop. So final velocity will be 0 meters per second. It gives us time of 11 seconds. And it asks us in problem B for displacement. However, we have to solve for acceleration first, because we're going to solve for displacement using the formula final velocity squared equals initial velocity squared plus 2 times acceleration times displacement, where we're going to solve for displacement, but we haven't been given acceleration yet. So to solve for acceleration first, we're going to have to do final velocity equals initial velocity plus a times t, which is time. So we know that we have a final velocity of 0, an initial velocity of 88 meters per second. We do not know acceleration yet. We know it took us 11 seconds. So you're going to have to solve for a by subtracting 88 from both sides. You're left with a times 11. Divide by 11, you get negative 8 meters per second squared equals acceleration. Now we can solve for displacement. Let's do a different color. So we can use the formula final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. So again, we know what our final velocity is, and you have 0, which is the same as 0 squared. Your initial is 88 plus 2 times negative 8 times t. So you're going to have to solve all of that through. Negative 88 squared is going to go over here. You're going to be left with negative 16d on this side. When you divide that out, you get a displacement of 484 meters, or you could round it off to 480 meters. There you go, it's done.